Hey guys, welcome to today's video that I'm pretty excited about, which is going to be modifying the firmware on one of these KSGER units, but this also applies to the Quicko units and probably any of the other knockoffs. You may need to recompile the stuff for the knockoffs, though. Although I guess these things are kind of a knockoff of a knockoff. So yeah, what we're going to be doing is taking this apart. So just take this panel off, front face off, so that way we can get to the microcontroller. It's on this front panel here, and we're going to flash it with some new firmware. This new firmware adds a ton of features to it. It also takes away some of the stuff that's unnecessary, like the real-time clock goes away, because when do you even need a clock on your soldering iron for? And yes, don't get started on, well, you got the flow times. Yeah, people using one of these don't really care about that kind of stuff that much. Yeah, and it's so small on the screen anyways for the original one. Okay, so yeah, I understand why they took away the feature. I guess a lot of people have complained about that, but yeah, I originally saw this on the EEV blog. So there's a whole thread on this. It's like 78 pages long. There's the GitHub repository. There's actually a couple of different people doing the same kind of thing here, but we're gonna focus in on this one particular one, and I find it to work good. So yeah, one of the features it adds is it adds support for the JBC tips, so you don't actually have to use these Hacko T12 tips. And the other thing it adds is a lot of customization to basically how many watts it's putting out, and you can change your PWM times on there, and it gives you pretty much full control over how this thing works. So I think it's pretty neat. I probably won't use it to its full potential of all the features it has, but I found it to be a worthwhile time to do and a fun project for myself. I like to challenge myself to new projects, so I saw this and was like, hey, I think I can do this. So tools you're going to need to do this is you're going to actually need a second soldering iron, because you're going to have to solder some wires onto it. You might be able to get away with just using some clips to clip on there, but really just you're going to have to solder some other wires on for programming it. And you're either going to need one of these cheap ST-Link programmers like this that are kind of clones of the real deal, or a J-Link will also work. But you don't absolutely have to have one of the two of those. You can use a STM32, like an STM32 blue pill like this. And there's some firmware out there you can put on these to use it as a ST-Link. So you don't really have to have one of the two of these, but if you, like, this is so cheap, you might as well just buy one of these and it'll work. So that's what you need for programming it. And then I would recommend also just replacing the microcontroller. So the original one, which is sitting here off of mine, I've already done this. This is, you know, the magic of editing. But yeah, so the microcontroller itself is readback protected on most of these units, so you cannot read back your old firmware. There are some attacks to do the readback, which is why I'm saving it still to do that. Yeah, I just replace the microcontroller, so that way you have the original one with the original firmware in case you brick it, putting your new firmware on there. So that's what I did, is I just replaced it because I had these microcontrollers on hand. I know this is not the best time in human history to be replacing STM32F103s. They are pretty hard to get your hands on genuine ones right now because of the chip shortage. You can use clones of them and they'll work too. Like the CKS 32s should work for you, although the ST-Links do not like to program those. Yeah, just food for thought there is you might have a hard time finding another microcontroller to replace it. I luckily had some on hand from doing this project here where I was making my own gauge pod. So I had some to do that with. So yeah, let's actually kind of get into this. I'm not going to go into too much detail about all the features it includes. You can get on the GitHub and read through the documentation to see what all new features you're going to get out of this. I'm just going to show you how to flash it with one of these and program it real quick, because I don't think I've ever actually showed the programming suite from ST on the channel before, so it's a good opportunity to show how to program with that, because I always just use my J-Link on the channel. But yeah, I should I want to show this one too. So that's what we're going to use in this video. We're not going to use the J-Link. These are a little bit more affordable for other people too. So I figured I should focus in on the more affordable tool. Okay, well now let's take this thing apart and see what we got to do to get this done. All right. So before we take this thing apart, let's go through the screen menu options real quick, just that way we remember what it all looks like before we flash the new software on it. So that way we can just see what's different. So first it takes a little while to turn on, and then we immediately have the soldering iron come on and heat up. And so then set temperature does that. Holding it down brings up the menu, and then you can change your sleep setting, your boost, cold. You can tell it what tip you have, stepping, password, screensaver, buzzer, voltage. That should be the low voltage protect, if I remember correct. Yep, it is low voltage protect that we were looking at, and the function's currently turned off on mine. So that's what the menu options look like. I know this LCD doesn't come across great on the camera. It doesn't flicker like that in person. It's just the shutter rate on the camera versus the refresh rate on the screen that does that. So, yep. That is it for the menus. Well, now let's take this thing apart and actually look at what is inside here. And remember, this is the one that I modified and grounded. This is the one I modified and actually added the ground throughout on here. So first we need a Phillips head for the back. And then next we need a Allen key for the front. Okay, so all that we need for programming it is this front face. We don't need the rest of it. Okay, and then you will see your STM32 in here that we will be flashing. So that is this chip right here that we're going to be programming. Okay, so real quick, before I get into programming it and actually doing that, let me just show you a quick overview of how I wired it up. It may be different for you because there's a ton of different revisions of the circuit board that are pretty much the exact same thing with just stuff moved around. So here's one of the differences that I had that you wouldn't see on the other ones is the SWD debug port was not labeled SWD. Most of them are labeled SWD, and it just has CD ground and VCC labeled there instead. So C is your SWD clock on your STM32 or on your ST-Link, and D is your SWDIO. So those are the only two pins you need for data, and then you just need ground here. This isn't like the J-Link where you have to have a VREF for it to work. So that's all you need to get it programming. And then I used I don't trust outputting power from one of these things. You could, in theory, for VCC, take your 3.3 volts out on this and should be able to program it. I don't know. I don't trust these things for outputting that. I don't want to put that kind of strain on my USB port on my computer. So what I did instead is wire up to the connectors here. So mine had the plug here that plugs in for power, but there were two blank pads here labeled 24 volt and ground. You don't actually have to give it 24 volts. It's using a... It has an LDO for giving the 3.3 volts to the microcontroller here. That LDO, it'll work at 12 volts, so that's what I'm giving it. I just hooked it up with 12 volts to program it. One thing that I did off camera is I replaced my microcontroller just because they write protected the microcontrollers, so well, read protected it, so you cannot read the data off of it. And so I did not want to lose the original data, so I took it off and swapped another one on. Okay, so I have it powered up right now, and as you can see with the microcontroller blank, nothing happens. If we had still had the original one in there, we would have the original screen coming up and it'd be saying like error because there's no soldering iron plugged in. But yeah, so this is set up it's with a blank microcontroller. So step one is to go to the website, go to his GitHub. I'll have it linked in the description. The easy thing is to just download the whole thing. So just go download zip, and then you'll just have the whole thing and unzip it. Okay, so yeah, the next step is to figure out which board you have, the exact one. Don't trust the software hardware version that it says on there in the when you go to the about page. So we'll go to version 2 schematics and take a look at these, and that one doesn't look anything like mine. That one looks kind of like mine. This one definitely looks a lot more like mine, except for the DFV portion isn't right. But none of them looked exactly like what I had. So that's the main thing is when I went through them all, none of them really matched it. Nice thing is you have a schematic to it too in here, because they're all pretty much done the same. So go into version 3 also. This one actually I would say is the closest one. I actually think this one is exactly it. So yeah, mine said in the software that it was hardware version 2, but this is definitely what I have, which is hardware version 3, which is why I'm saying don't trust what the software says. So since we've identified that mine is a version 3 and not a version 2, we're going to load this bin, but what we're going to use to do that is the cube programmer. So let me just make sure I got this out of the way of the camera there. So now with the ST-Link hooked up to the microcontroller, well, hooked up to the circuit board and then plugged into the computer, we need to go and connect to it. So now we've connected and we need to go to the program screen here, which is this one. We're going to browse, we're going to go to version 3, and we're going to open that bin. And then I always just have it verify the program and then just run the program when it's done. So we have started the operation successfully and we've downloaded it successfully in that. So it should be running now. Let me look over here. Yep, we now have it running and it has the first time start here. So yep, I have a T12 set up and there we go. It's got basically the error screen saying that, hey, I don't have anything plugged in. So now let's put this thing back together, test it and see how it performs. Insert X number of hours meme here. All right, so I spent a couple of hours diagnosing a weird problem that mine was having, but this was a freak issue that nobody else had seen yet on the forum. So I'll just chalk it up to I had a weird issue. Basically what was going on with mine is my 3.3 volt rail was dropping and it is the voltage regulator was the problem. I didn't actually replace the voltage regulator. All I did was turn down the contrast on the screen and that was enough to resolve my issue. So let's go ahead and boot this up though and see how much faster it turns on. Look at this, this is awesome. So turn the switch on and it's on. This doesn't take forever like the original firmware on these. The original firmware, you would wait like forever. It took so long to boot up. I don't know. I don't know how to describe it. I didn't time it. I don't know exactly how long the old one took up and how long this one took up. But yeah, the splash screen does add extra time. The guy that made this mention, he's like, yeah, the splash screen's not really doing anything. It's just there to look cool. But yeah, so it turns on really fast. And so the issue I was having is if I would turn the rotary encoder, the screen, it lights up like that. That was enough to make the whole thing shut off. So I just had to go into my settings. So let's hold this down, go to system, and then go to contrast. And anything over 3 was too much, it will shut off. So 0, 1, 2, and 3 all work for me. So I have it set on 3. And 3 is plenty bright. I really don't need it any brighter than it is. But let's go back here. And so let's go through some of these settings here, just that way you get an idea of what you get. Okay, so you had basically your normal settings right here where you got your max temp, min temp, standby, all your normal stuff here, your sleep, your boost, your power, your, and yeah, so this one's actually pulling, you can adjust the power rating on here. And then some of the other things, we have our delay, you have filter settings now, those are new. And then you have some more system settings too in here. You can change it from awake to a stand where it's got the switch. The switch has to be closed is off and open is on, I believe was what the instructions said. Mine's going to be on shake though, because that's how my pin's set up. Yep, you have that same setting where you can change it when it boots up. Is it on or is it off? So that way you don't have to have it turn all the way on. So you got a lot of settings here. I'm really not going to go into all of them. I just wanted to kind of give you the basic thing here. You can edit your tips and change a lot of different things in here. It mentions in the setting in the description of this not to mess too much with that because you can actually damage stuff. It has a calibration mode, and that's really it. All right, well, y'all didn't think I was going to end the video without showing you it in action. So, yeah, I'm sure if you're familiar with the channel, you've seen me mess up working on one of these on a live stream before. These things have a ton of thermal mass, especially because of heat sink. So let's see if... So this is the stud for the heat sink. Let's see if we can just melt some of the solder around there. So there's a little flux on it. And let's see if we can drive that in there. I see it starting to flow. We're getting there. I think I'm going to have to turn it up a little bit, though. These things take a ton of heat. Because of course they do. It's a heat sink. Oh, there we go. Yeah. Yep, that's it. The whole thing's melted. So, yeah, it can do it. So, I'm impressed with that. Obviously, this has not been calibrated all the way because I don't actually have the thermometer for doing calibration. But I do know somebody with one, so I want to calibrate it here soon and actually compare it to the JBC. I know the JBC is going to outperform it because it's got the Hacko T12 tips, and those JBC tips do outperform the Hacko T12. Sorry, it's just true. But I would also have to be comparing it with a different handle. I don't have the JBC 245 though, so I'd be comparing it to a 210, which is not a fair comparison. So yeah, I'm happy with this modification. It's really not that difficult to do. It didn't take long, and again, I know I had problems, but I have not seen anybody else report having this same problem I've had. I really think it might be just due to the fact that I used my unit a lot and then I haven't used it in a while. So mine's an old, it's an older unit. I bought it, I think 2 years ago now. And yeah, it's had a fair bit of use. And I think that LDO that's on here, or voltage regulator, I actually haven't looked at the data sheet to see if it's actually an LDO or if it's just a regular voltage regulator. I would assume since it works from 12 volts to 24 that it is a LDO. But yeah, the voltage regulator just isn't giving out quite enough current for it to drive the screen in the manner that this firmware does, because the refresh rate is definitely higher on this too than it was on the old one. As you noticed on the camera, it did not flicker nearly as much. Let's go ahead and bring that up, get it to about the same distance as we had before. See, earlier, remember earlier in the video, the screen was flickering a lot, and now not so much. It's a little more steady. So the refresh rate is definitely higher on this guy. So I mean, look at how fast that boots compared to before too. So yeah, with that higher refresh rate and the way it lights up the screen, I really think that was the issue with it shutting off on me. Is just my particular board does not will not run. The voltage regulator just can't support it the same. I did rule out dirty 24 volt power supply. I actually off video added a capacitor to the 24 volt guy right about there too, just to filter out any extra, you know, noise that might be coming across or anything. But yeah, no issues there with the 24 volt rail. I would actually put it on the oscilloscope and was only seeing about a 600 millivolt peak to peak deviation on there, or noise. So it really wasn't that noisy. And so I don't know. For what you're getting here for a $60-$70 unit, I think this has a really good power supply in it. And with this firmware, I think the firmware is an improvement to it. Just be aware, if you have the exact same one as me, where you have the same circuit board, you may run into just having to turn down the contrast a little bit on the screen. I have not heard of anybody else having problems with the KSGER units, though. And there's like 5 or 6 different circuit boards that they use that they called the same revision. You'll see them in the photos when you look at the firmware. I hope you guys liked the video. I hope you thought this was as cool as I did. I thought this firmware is cool. Somebody made open source firmware that you can edit and do whatever you want to with it. Plus, we have the schematics for this, so, you know, if you wanted to make your own version that had, you know, maybe a switch for a pump to do desoldering, or, you know, switch for a fan to do a hot air station, you can do whatever you want with kind of the same circuit design as this. So I think it's pretty cool. I hope you guys liked the video, and I'll see you in the next one.